Okay, we are recording. So first of all, I want to remind you that there is already a homework and you have to work on this homework. So some of you did send me email to tell me with who they want to work. So as you can see, we still have some people here, 1, 2, 3, 4, 5, 6 people that have not decided. So please be sure you send me an email and copy to your partner every time that you talk about the homework or the groups. Don't forget to send to your partner. So those are the groups that we have up to now. So if you send me an email, you should see your name and the name of your partner here. Okay, so please start working on the homework, on the first homework, which is where you have to learn to work with Linux. So last time we were seeing the CSR encryption algorithm. So I'm going to do a small review on it. So basically what CSR was doing, it will take the alphabet and shift the letter. So it will make a rotation of the letter. And the key will be the number of shifts that I'm going to do. For example, if you look here, let's say that outside we have the plain text and inside we have the ciphertext. If the key is 0, I don't shift anything. If the key is 1, so the one that is inside, I will shift it 1 position. So the A in plain text will become a B in ciphertext. A B in plain text will become a C in ciphertext, blah, 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 okay? This is an example. If the key is 2, so A will become a C, a B will become a D. And this is an example if the key is 3. A will become a D, a B will become a E, blah, 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 okay? So we have some formula to encrypt and to decrypt. We already talked about them, so I just review them with you. And we did an example here. For example, let me see. Well, first, we did this example. Meet me after in the park. If I use a key of 3, it will be this. Okay? So it's very easy to go. For example, you take the M, which is a plain text, and the M will become a P. So you replace the M by a P. Then you have a E. A E will become a H. So you replace the E by a H. Another E will become a H. Then you have a T. A T will become a W. And you go on like that on all the letters one by one, no? And we were thinking about, okay, I have, for example, this ciphertext. It was encrypted with key 3. How do I come back? So it's very easy. You, for example, what you need to do it, let me see. Yeah, we don't have both here. So what you need to do it, you can use those formula that are here to do it. And you will come back to the plain text, no? Or if we have unfortunately here we don't have it, but if I put the 2 road, it will be easy to go from the ciphertext to the plain text, no? Okay, so here, let's say that we have this ciphertext and we don't know the key. And we want to go to the plain text. So I propose you to do a brute force attack. A brute force attack is, let's suppose that the key is 1. If the key is 1, let's decipher that and see what it will be. Then we continue. Let's suppose that the key is 2. Let's decipher that with the key is 2 and let's see what we get. Up to the last key. The last key is 25. Let's suppose that the key is 25. Let's decipher that and see what we will get. And 1 will be something that we can understand. So that will be the key. And we will have the plain text message. So to do that, because there are 25 keys, we better do that with a computer. So we were trying to do a program where we will feed the ciphertext and we will get the plain text. So I started to make some review on Python. For example, we started to see that if you pass command line argument, you can work with them, no? So remember that there will be an array that is called sys.argv, and this will be sys.argv sub 0, sys.argv sub 1, sub 2, sub 3, sub 4, sub 5, no? So we were showing how we can show the argument here. We did a small program. So since we already did that, let's do our program. So the first thing that we need to check in our program, let me remove that. That was what we see last time to manage the argument. The first thing that we need to check that the person passed exactly the name of the command on one argument, which will be the ciphertext. So the person, when it views this command, will type something like that, no? Break the code, and it will put the ciphertext here. So the ciphertext that we want to break, let me copy it, is this one. Is this one. So let me copy it here and put it in the virtual machine. So we want to call the command like that, and we want the command to show a 25 possible solution with each key trying to decipher this ciphertext. So the first thing that we have to check here, if we have two parameters, the name of the command and the ciphertext. If it's not the case, we are going to tell the person how to use the command. So we are going to say if the length of the array is called sysargv, is not 2, I have to tell the user how to use the command. So I will tell it usage on the first line, so it knows how to use it. And I want to send that to the standard it's file std error. I want to send that to the standard error. Then I will tell the user the name of the command, and you have to put the ciphertext here. So ciphertext dot format. But the name of the command will be in sys.argv sub 0. And I want to exit. So sys exit 1. Remember that when I exit with a status code that is different of 0, there were a problem. And if I come here, there were no problem. I'm going to exit with a status of 0. Let me save this file and let's run it. So for example, if I run it like that, it didn't show me any error. If I ask him what is the exit status, is 0, which means that I exit here. Now, if I run it and I forget the ciphertext, so it's sys here. It's not sys standard error. So it will be sys also here. File equal sys standard error, no? Okay, let's do it again. If I forgot the ciphertext, import sys. Let me see, Python 3, import sys dot stderr std standard error. Okay. Let me exit Python. Let me do it again. So if I just run it like that, look, it gives me a clue. It's telling me if you want to use this command, don't forget to put the ciphertext after the name of the command. Okay, that's fine. So we are sure that the person has typed the ciphertext. So instead of working with sys argv_1, I'm going to call a variable. I'm going to call it ciphertext. And I'm going to store sys argv_1. Okay, so now I want to show all the possible clear text. So there are 25 different possible keys. So I'm going to do a for key in range. So I'm going to start in 1 and go up to 25. So 1 inclusive and 25 inclusive. Remember that this 26 is not inclusive, no? So I'm going to parse I'm going to convert the string according to the formula that we have to a plain text. So let me show you the formula again. Let me just copy the formula here. So the formula is say that if we want to go to the plain text, we can use this one. Let me copy it. Hopefully it will go in the virtual machine without problem. Let me put it here as a reminder. Paste, yeah, I was able. So how we go to the plain text? So first, let's define a string that is called plain text. And I start with an empty string. Then, for this key, I'm going to go character by character and compute the plain text, no? So I'm going to do another for character in ciphertext. So one character at a time. I'm going to first get the plain character. So let me call it plain char. How do I get the plain char? Char is the cipher character. I need to use this formula. So this formula said, tell me what? Hey, you take the ciphertext. So the ciphertext is in char. Okay, but remember, it's a letter. So I need, let's say it's a capital letter. I need to put it between 0 and 25. You remember that? It has to be between 0 and 25. So how do I put it between 0 and 25? I ask the ASCII code of the character. And if it's a capital letter, I have to subtract 65. So with that, what is with ORG? With that, I have the ciphertext between 0 and 25. Okay, when it's between 0 and 25, I have, look at the formula. I have to add 26. Then I have to subtract the key. On all this, I have to do the modulus 26. So modulus 26. And this will give me the plain text. But the plain text in this moment is not a character. So to transform it to a character, it will be between 0 and 25. I'm going to use the chr function that we saw last time. So chr, put parentheses here of all this, plus 65. So that will be the plain text. So I can do now, the plain text will be the previous in-text that I have, plus the character that I just transformed, no? Plain char. Okay, and after doing that, I can show when I finish with this for, I can print the result. Print, so if the key is, let's put something here, let's put it over 2 characters. The plain text will be, and I'm going to show the plain text. Plain text will be, and I'm going to show the plain text here. Dot format. So if the key is, I'm going to show the key here. On the plain text, I have it in plain text. Okay, that's it. So let me remove this formula. And if I have no problem. Let me see with the parentheses here. This is so many parentheses. 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. Okay, looks like it's okay. A better editor will show me which parentheses go with which parentheses. Okay, let's try this. So let's try this, and let's see what we got. So look at, if the key is 1, the plain text will be that. Oh, sorry, forgot something. Not all the characters are uppercase, so I should write something like that. If the character is an uppercase, how do I check if a character is an uppercase? That the character that, wait. If the character that you give me is an uppercase, so an uppercase is something that is between capital A and capital Z. So if it is between capital A and capital Z, I do what I just show you. Okay? So otherwise, if it is a lowercase letter, I will do something that is very similar with lowercase letter, no? So lowercase letter are between lowercase a and lowercase z. Let me copy these two lines and just change them. So here, lowercase a is 97, the ASCII code. And I'm going to put 97 here also, and that will be it. If the character is something else, like for example, a digit, or the character is a space, I am just going to concatenate the character at the end of the plain text. For example, here we have space. So this space, I should not change it. Okay, let's see if it's work. So let me run it again. Okay, so look, if the key is 1, that will be this, the plain text. Is this English? No, so the key is not 1. If the key is 2, the plain text will be that. We cannot understand that. 3, 4, 5, we cannot understand it. So if you look, if the key is 16, we have easy to break. So it's the only one that came back to something that we understand, which means that the key was 16. Okay? So you see this program do a brute force attack. It try all the key. It say, if the key is 1, when I decrypt this, I will get that as a plain text, as a clear text. But this is not something that we understand. So it cannot be, the key was not 1. So we try with the key 2, it was not key. It was not the key. We try, and one of the key, which is 16, give me something that I can understand, easy to break. So the key was 16. Okay? So we can install a software. There is a software that is called Caesar in Linux. That we can install a software Caesar that will do the job for us. So let me install it. So first, I'm going to switch as a sudo user. Let me see if I belong to the sudo group first. Did we put, yeah, I belong to the sudo group. I can see it here. So since I belong to the sudo group, I can do a sudo -e. It will bring me as a root user. My password as Eric is internet2. So let me put internet2. If I check now my identity, I am the root user. So first of all, because we installed this Debian like 3 weeks ago. So of course they have updated the repository. So before I install another software, I should bring a fresh list of all the software that are available in the repository. So I'm going to do apt-get update. So this will go to the Debian repository and bring a fresh list of software. And the one that I want to install is called Caesar it is in BSD game. So let me ask it about Caesar. So here it's telling me it is in BSD game. It tells me that there are two candidates, but I already know that it is in BSD, Berkeley Standard Distribution games. So I'm going to do apt get install BSD game. It will go to the repository. There is one dependency, so it will have to download BSD game plus the dependency, So before installing it, tell me there is one additional dependency. Do you really want to install it? I'm going to say yes. So it download the dependency first, it download BSD game, it install the dependency first, and it install the BSD game. So BSD game, it's a lot of files. If I want a list of the files, there is a command that is called dpkg.S. You put the software that you install, and it will show you a list of all the files that were installed. So you see all these files were installed. The one that I'm interested in, because there are many games here, as you can see, is this one. It's called Caesar. So of course, you also install the manual of Caesar. So if you look, those are manual. So there is a manual for Caesar. I can see that he installed the manual for Caesar. So I can do man Caesar to know how to use it. And it just tell me, you put Caesar on the key to use it. So for example, look, we know that, let's go back here and verify something. So for example, meet me after in the park. If the key is 3, should be that. How can I verify it? With the software that I just download. So let me copy that so we will not have to do it. Okay, go back to my virtual machine, and we have the software that is called Caesar. So I want to tell encrypt this plain text with Caesar using a key of 3. How can I do that? Let me show you the man again. Man is there, and it say you use Caesar and specify the number of rotation that you want. And the input have to be the standard input. So a way to use it and do, okay, input. Let me go back to a normal user. So I can do Caesar 16. And every time that I type something here, this is the plain text. Look at, this will be the ciphertext. So let's verify that this ciphertext is the one that we have there. Oh, the key was 3. I start with a key of 16, sorry. So let me exit, Control D, the key was 3. So let me put the plain text. The ciphertext is PHHW. Let's compare that with what we have here. So let me try to put both of them here. This one. It's not easy, no? As you can see, okay, here we can see both. So we have the plain text here, which is there, and the ciphertext is PHWW, PHDY. As you can see, it did work. So for example, let's see. Another way to use Caesar will be this way. I can do, for example, echo the plain text. Let me just paste it here. And I send it through a pipe to the command Caesar, saying that I'm using a key of 3. Look at it. Okay, this is not interactive. If I do like that, it's interactive. So I can type that. And if I type, of course, A, B, C, D, so A become a D, so it will be D, E, F, G. Okay, it's interactive here. If I do like that, A, B, C, D, it's not interactive. It's telling me the ciphertext, if you use 3, will be D, E, F, G, as you can see. Okay? We can verify, we did some other. So for example, let me see what we have. For example, here they gave us a ciphertext, and they ask us to find the plaintext, and the key was 3. We know that the plaintext, we did it, the plaintext was find the plaintext. So if I copy this, find the plaintext, let me copy it, and return to my virtual machine, and do this with a key of 3, it should be what we have there. So let's see. I need to put this one. Let's put it like that. And look at ILQG space WKH. As you can see, it's the same one, no? So let's see here in the exercise that we was doing recently, we discovered that the plaintext was easy to break, and the key was 16. So let's verify that we will have that. Here I have easy to break. Let me just copy it. So if I say using CSAR, encrypt easy to break with the key of 16, that will be the result. So let me show both to verify. So here we have the ciphertext in the PowerPoint, and we put the PowerPoint. So UQIO space GE. So as you can see, it's the same one. Okay. So that was true. What we did, our program did allow us to find the key. The key was 16, and the clear text was easy to break. So this is very easy to break. This is not a good code. So at the time of Julius Caesar, that was enough. But today, it will not be enough. It's too easy to break. As you can see, there is only 25 possible key. I look at the 25 possibility, and I can say, oh, that was the key, and I know what is the ciphertext. Okay, so install CSAR in your computer. We just did that. Convert, I enjoyed the course with a key of 1, with a key of 5, and a key of 20. So you should be able to do that, no? If I need to convert that, encrypt that. So I just do, for example, echo the plain text here, and I send it to CSAR. So they were saying with a key of 1, 5. So that will be with a key of 1. So key 1, 5, and 20. So that will be with a key of 5. As you can see, it's different, of course, no? This is key 1, and this is key 5. And the other key was 20. So if I do it with a key of 20, I will have a different ciphertext. Of course, every time that I use a different key, I have a different ciphertext. Okay. So the next exercise, what is the result of you take a plain text, you encrypt it with CSAR using a key of 5, and you take the result and you encrypt it again with CSAR with a key of 3. What will be the result? So I applied 2 times CSAR. The first time the key is 5, and the second time the key is 3. So what will be the result?
Isn't that just like a key of 8?
Exactly, because you shift. If you shift it 3 position, then you shift it 5 position, then 3 position, in total you shift it 8 position. So it will be exactly using the CSAR encryption algorithm with a key of 8. So if I want to demonstrate that, how can I do that? Show me a way to demonstrate that. Look at what we can do. We can take the alphabet. It's going to take me some time to write the alphabet, so I need an easier way to write the alphabet, no? Write echo. I can even A, B, C, D, E, F, G, H, I, J, K. It's taking me some time. So I'm going to do something a little better. Okay, so this will expand. So for example, you can say, show me the integer between 1 and 7, or show me the integer between 100 and 120. Okay, they are all there. So it will expand on what you want. So here I say, expand all the alphabet from A. I can say from, for example, from E to G, if I want, no? And here are the letters. So from A to Z. But I don't want the space that are between the letters. So I'm going to use the traduc command with the delete option, delete the space. I have all together. So I have the alphabet from A to Z. So if I call Caesar of 5 first, look at, it said that A will become a F, a B will become a G, a C will become a H. Okay? For example, a V will become an A. Okay, if I do Caesar 5 and then I do Caesar 3, look at the result. So A become a I, a B become a J, blah, 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 blah. So instead of doing that, let's verify that if I do Caesar of 8, I will have the same string here. So this string is equal to this string, which show that if you apply first Caesar of 5 and then Caesar of 3, which is what the exercise say, no? You apply 5 first, Caesar of 5, then Caesar of 3. It's the same thing as applying Caesar of 8. By the way, you can apply Caesar of 3 first and Caesar of 5. It will be the same result, okay, because they just add up. So 5 plus 3 is the same as 3 plus 5. What will happen if I do that? So I take a plain text, I encrypt it with the Caesar algorithm using a key of 11, then I take the result and encrypt it again with a key of 20. So it will be the same as Caesar of 31. And Caesar of 31 is the same as what? Caesar of 5, isn't it? Because remember the key is between 1 and 25. So Caesar of 31 have to be something between Caesar of. So since we go modulo 26, 31 modulus 26 is 5. So if I do that, 11 and then 20. So let's check that. We are going to do 11 and then 20. So I pretend that it will be the same result as if you just do 5. And you can look at it here. Okay, this string, which means that I'm changing the alphabet to this one. Or I'm changing the alphabet to this one, I'm changing it to the same one. So it's the same thing at the end. Okay? Now, what will be this one? So I apply Caesar of 19, on the result I apply Caesar of 7. So 19 plus 7 is 26. So I will get the plain text. There will be no change. A will be a B will be a B. So let's do it. First 19, then 7. So I go to my virtual machine and I say, if I apply 19 first, then 7, look, I came back to the normal alphabet. There is no change. A become a B become a B, a C become a C, because 19 plus 7 is 26. So of course, if you use key 26, you make a full rotation. And if you make a full rotation, you come back to the initial position. So there is no change. What is if I use the key of -6? So instead of rotating the ciphertext counterclockwise, I'm going to rotate the ciphertext clockwise. So if I do with -6, what will happen? it will the same as encrypt 20. If you do it with -6, it will be the same as encrypt 20. Remember that we are modulus 26. So -6 is the same as 20. So if you do decrypt with a key of 10, it will be what? So do you realize that, let me show you something. If I take a plain text and I encrypt with 11, so I go from the alphabet to this. How can I go from this back to the alphabet? Which means, how can I use CSAR to decrypt? So if I do echo and I take this ciphertext, how do I use CSAR to come back to the normal alphabet? What will be the key that I should use? 15, isn't it? If you use 15, you come back. So for example, let's say that we have the previous exercise where this was, what was the key of that? I don't remember. The key was 16. So the original was easy to break. So look, if I take that and I apply CSAR with 16, I get this one, which is the ciphertext. Now, if I take the ciphertext and I want to decrypt it, decrypting, if I use a key of 16 to decrypt, I can use CSAR with a key of 20. 16, with a key of 10, sorry. Okay, because 16 plus 10 is 26. So it's modular 16. So what you encrypt with key 16, you can use the same algorithm to decrypt, and you use another key, which is key 10. Okay, why? Why this happen? Because you have two roads. If I take the inner road and I move it 60 position, how much position is left to come back to the original one? 10 position. So if I do 60 position, then 10 position, I did 26. And if I do 26, I come back to the original one. So it's why if you do, for example, let's do it this time with 7. If you move the inner road 7 position, how many come back to the original text? 90. Need to do it 19 times. So for example, if I take easy to break, let me take easy to break, and I encrypt it with CSAR using a key of 7, it will give me this ciphertext. Now, if I take the ciphertext and I keep rotating, I need to rotate it another 19 position to come back to the original. You see? So this exercise that asks you what is decrypt of 10? Decrypt of 10 is encrypt of 16. So when you have that, so the decrypt of 4, you can change it with a encrypt of 22. So that will be encrypt of 11, then encrypt of 22, then encrypt of 20. So 11 plus 22 plus 20 will give us how much? 53, isn't it? And 53 modulus 26 will give us how much? What? 2652, yeah, it will be 1. So this is exactly encrypt of 1. You're right. If I do that, what will happen? I don't make any change. I rotate 13 position, then I rotate another 13 position and come back to my initial position. So if you use Caesar with a key of 13, and you take the result and use Caesar again with a key of 13, you come back to the original text. You come back to the plain text, no? Okay, so what was the key used to encrypt the following text? So we can just use our program that we did. Let me copy it and see. So the program was called break the code. I'm going to put here the plain text, the ciphertext, and there is one that should be that we should be able to understand. Do you see it? Which one? The 19th, exactly. Cybersecurity threats are growing. So that was the key that the person used. So you see, look at Caesar, the software Caesar is so nice that you can do something like that. Echo, I put the ciphertext, and I send it to Caesar. And it will tell me cybersecurity threats are growing. So it's compute all of them. Then he used a dictionary of English. So for example, let's try the first key. This is not in the dictionary. This is not in the dictionary of English. This one, this is not the solution. So let's try with key 2. This is not in the dictionary. This is not the solution. So I keep going. When it arrives here to 19, it say, oh, cybersecurity is in the dictionary. Threat is in the dictionary. R is in the dictionary. Growing is in the dictionary. This is a solution. So it shows us that the solution is cybersecurity threats are growing. So the program is a little more advanced than our program. We could do our program a little more advanced and check every word with a dictionary. If every word belongs to the dictionary, we can say this is the solution. The key is this one, and the plain text is this one. Okay? We didn't do that. We show all the possibility, and we have to scan all the possibility to determine what was the key. The key was 19, and what was the clear text. But this program do a little more than what we have done. Okay, so if you want to install, the commands are here in the slides, no? So let me continue. So look at what they say here. Rather than just rotating the alphabet, let's go to a small evolution. We can shuffle the letter arbitrarily. So we can move them around. Okay? This is known as the simple substitution cipher. Another name for it is the monoalphabetic substitution cipher. I will use simple substitution cipher. So each plain text letter mapped to a different random ciphertext letter. So for example, this is a possibility. I will change the A for a D. I will change the B for a K. I will change the C for a V, blah, 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 blah. This is not a rotation. This is, you shuffle them. Okay? You put them in this order. So let's say that you have this plain text. Define the east wall of the castle, and you want to encrypt it. So look at, you have a D. A D must be a Q. Then we have an E. A E must be a F. So a E must be a F. Then we have a F. A F will be an I in the ciphertext. So a F become an I. Then we have an E. A E will become an F. Then we have an N. An N will become an X. Then we have a D. It will become a Q. Then we have a T. A T will become a U. Blah, 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 up to the end. So what is important here, we need the 26th letter of the alphabet. So if you check, the A is there, the B is there, and each letter have to be only one time. So the C is there, the D is there, up to the Z. So you have something that is bijective. You can go from here to here, and from here to here. So the secret that you need to memorize is this. In Caesar, it was an integer that you need to memorize, between 1 and 25. That was the key. Now the key is the alphabet in a specific order. So how we go from the ciphertext to the plain text? So look at, for example, we have a Q here. So we check where is the Q here. It is there. So we replace the Q by a D. Then we have an F here. The F in the ciphertext will be an E. Then we have an I here. So we search for the I, it is there. The I in the ciphertext, in the plain text will be an F. So this is the way to come back to decrypt, okay? Okay, they say if the key is this one, relate the simple substitution cipher with the Caesar cipher. What can I say here? Here we didn't shuffle the letter, we just rotate them. Do you see that we just rotate them? Because if you look here, we have A, B, C, D, E, F, G. We have the alphabet. After the O, we go to P, Q, R, up to Z. So this is, we can say this is the simple substitution cipher, but at the end, it's also the Caesar cipher. What is the key in this case? So let's see. The A, if the A come here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the key is 15. Let's verify that with our computer, no? So let me try to have both of them here. So I'm going to do, I need the alphabet. So I need to generate the alphabet first. So A to Z, then remove the space. Okay, we have the alphabet. And do Caesar of 15. Caesar of 15. And let's see if the same one. So it starts with P, Q, R, S, T, P, Q, R, S, T, as you can see, and go up to O. That was Caesar of 15. Okay? Let's see the second question. If the key is, what will be the result of encrypting the plain text? So let me do it. The key is this. We should verify that the key is length 26 and have all the letters of the alphabet. So you should verify that, no? A key must be length 26 and must have all the letters of the alphabet. So I build a copy of the key. Let me go to an editor. Let me put here cipher equal, and let me just paste what I copy. Let me put here plain equal, and let me put the alphabet. So I need the alphabet. I'm not going to write it, so I'm just going to ask the computer to generate the alphabet for me. So I don't have to spend a lot of time, and I will not make any mistake. So this is the alphabet. Let me copy it and put it here. So as you can see, A will become a L, a B will become an E, up to a Z will become an R. They give me see you soon. And I want to know how, if I use this key, what will be the result. So let me go back to my virtual machine. In text is see you soon. So what will be the ciphertext? So look, S become a H, so H. Then a E become a F, so FF. Then a Y become a K, isn't it? A O, do you see it? Oh, I need to make it bigger. How do I make it bigger? Save it as a file. Try to make it bigger. Control Shift. Oh. Okay. This one, at least I don't see how to make it bigger. I hope you can see it. So let me edit again the file. Okay, so O will become an N, a U will become an S, a S will become an H, a O will become an N, and a N will become a B. So that will be the ciphertext, isn't it? Okay, let's ask the computer to do that for us. So what can you write? Give me a command that you can write that will show us that this clear text will become HFF, what is written there. What can we do with the TR command? So the output of the echo command, I'm going to send it to the TR command. And I'm going to say what? Translate this into this. And that's it. And look at the result. HFF, K and S, H and B. So of course, I could have used something a little shorter. If I need the alphabet here, I can just use that. And it's giving me exactly the same result. Okay, this is a range from A to Z. We have 26 letters. So the A will become an L, a B will become an E, blah, blah, blah. Okay? So we can use this command, which is very powerful, as you can see, because it helps us to resolve that. Okay, let's see the next exercise. A message was encrypted with the key, this key. The coded message is shown below. What is the original message? So that's a message. And you know the key. And they ask you what was the original message. So let's do it. Let me edit. So we know that the cipher is this one. Cipher here. Let me put below the plain text. The key, let me copy the key also. The key was this one. Oh, it's the same key. Yeah, it's the same key, no? Okay, so let's go back. So how we go to the plain text? So O will become a J in the plain text. Then we have a H. Where is the H here? H become an S? Okay, I don't see it, but okay. H, where, oh, okay, the H is here. So the H become a S. Then we have a S. S become a U. So we have JSU. Then we have a M. M become a I. Then we have M is there. It's become an I. Then we have a H. H, where is the H? H. The H is here. The H become a S. Then we have a V. The V is here. It's become a M. Then we have a K. A K is here. It become a Y. Then we have a S. A S is here. It's become a U. Okay, if you do it, it will be that. JSU is my university. So now, how can I use the echo command? And I give you this, and I want you to come back to this. So it will be very easy, no? So what we are going to do is echo the ciphertext that we have. So the ciphertext is this one. We are going to say translate. So it's the inverse operation. I'm going to translate this into the alphabet. So I just put AZ here. JSU is my university. Okay? Let's see the next exercise. Giving a key K1, there is a unique key K2, such as you take the plain text, you apply the simple substitution cipher with a key 1, you take the result and you apply a key 2, and you come back to the plain text. So they say, if I give you this key, that was the key that we previously used, find the second key that will do that. That will come back when we apply 2 times the simple substitution cipher. It will come back to the original text. So it's easy to find, no? How do we find that? So let's see. Look at. So we need, when we apply 2 times, let me copy that. When we apply 2 times the algorithm, we need to come back to the original letters. So let me put here cipher and plain. So look. No, let me do it. No, let me put it better like that. I think it's easier to understand. So look, A will become L. So I need a second application of the same algorithm, the simple substitution cipher, to change a L back to a A. So look, let's replace all this with nothing. We don't know them. So A become a L. Now I have to say a L come back to a A. Isn't it? So when I apply 2 times that in the row, I come back to the original text. A become a L, and I apply with this key that we are looking at a key, which is key 2. This will be key 1 and this will be key 2. So it have to take the L and come back to a A. So a B become a E. So a E will have to come back to a B, isn't it? A C become a Q. So a Q will have to come back to a C. A D, A. So A will have to come back to a D. So a E become a F. F will have to come back to a E. A F become a P. So a P will have to come back to a F. A G become a W. G become a W, so a W will become a G. Then we have H become a J, so a J will become a H. Then we have I become a M, so M will be a I. Then we have a J become a O, so O have to become a J, no? If I make a mistake, let me know. A K become a D, so a D will be a K. A L become a X, so X will become a L to come back. L become a X, I did it, no? So a M become a V will become a M. A N become a B will become a N. A O become a N will come back to a O. A P become a Y, so Y will come back to a P. A Q become a T, so a T will come back to a Q. A R become a C, so a C will come back to a R. A S become a H, so will come back to a S. A T become a Z, so a Z will come back to a T. A U become a S, so S have to come back to a U. A T become a V become a U, so U have to go back to a V. A W become a I, so I have to be a W. A X become a G, so a G go back to a X. A Y become a K, so a K come back to a Y. And a Z become a R, so R have to come back to Z. How do I verify that with my computer? I did that manually, which is the worst thing that you can do. Imagine that we have 200 letters in the alphabet. You will do that for 200 letters? It's crazy. So now, of course, we have a computer for that. We can ask the computer to do it. So if I just want to verify it, what can I do? This is the alphabet. So I can say, if I apply this and this in any order, I should come back to the alphabet, to the original alphabet. Let's apply first this one. So I will say translate the alphabet with this one. Of course, the same one. Then translate the alphabet with this one. And we should come back to the original alphabet. And as you can see, we come back to the original alphabet. And if I change the order, so this is key 1 and this is key 2. If I put key 2 and key 1 in other order, it should come back to the original alphabet. So another way to do it, find another way to do it. For example, here we just verify it. How can we generate it? How can I go to this? What should I do to go to this? I can do what? Here we have the alphabet, no? So we can say translate what? I need this one. So if you are going to encrypt, you say translate the alphabet to this. If you are going to decrypt, translate this to the alphabet. Look at it. DNR, DNRK, BE up to LPT at the end. You see? So you have big tools here to do that. So of course you need to develop this because this is what people do in security, no? They develop algorithms like that. So the key K2 is the one that we just show. How you can use the TR command in Unix to encrypt. How can you we show that, how we can use the TR command to decrypt. Not that you can use AZ to have all the capital letter. Okay, we already saw that, so we can just continue. Okay, so when generated key, it is popular to use keywords without repeating letter. A keyword that don't have repeating letter is called an isogram. For example, zebra. Zebra, the Z is only one time, the E is only one time, the B is only one time, the R is only one time, and the A is only one time. So instead of memorizing a key like that, we cannot memorize a key like that. We have to write it down. And it's dangerous if you send somebody on a house and the key is writing down in somewhere on the person. Now, if you tell the person, memorize zebra, and when you arrive there, you tell the person the key is zebra. Look at how we can generate a key which is complex. So we will write first zebra. As you can see, zebra is here. And then we will write all the missing letter of the alphabet after removing zebra. So it's going to take me some time to write that. So let me show you. Because I need the alphabet. Let me generate the alphabet here and try to, can I bring it to pen brush? I'm not sure, but we're going to try. Pant. Let's do it bigger letters. It's be like that, no? Too small. Okay, so let me now write here zebra. Okay. And keep going. So we have the Z, so let me suppress the Z. Let me use something bigger on red. So let's suppress the Z. We have the E, let's suppress the E. We have the B, let's suppress the B. We have the R, and we have the A. So what is left is C, D, F, G, H. Okay, I go up to Y. Okay, so once I suppress all the letter, I just keep the alphabet, what is missing. So if you use zebra, so you have the zebra here, and all the missing letters are here. So that will be your key. So for example, they say here as an exercise, using the previous method to memorize only one keyword and not the 26th letter on the order of the 26th letter, what will be the key if you use downstream? So first we have to verify that in downstream there is no letter that repeats itself. There is only one D, there is only one O, there is only one W, there is only one N, okay? So what will be the key? So I need you to tell me how we will find the key here. So we have downstream, let me copy downstream. And of course, I don't want to do it by myself. I want the computer to tell me what will be the key. So of course, we will have the alphabet that we are going to shuffle, and it's going to start with downstream and the missing letters in the order. So what can we do? So I need the alphabet first. Remove the right space. I have the alphabet. And I have to remove the D. I have to remove the O, the W, the N, the S, the T, all the letters of downstream. So what should I say here? So I can say translate, suppress all the letters that belong to downstream. So what will be the key? The key will be downstream, followed by that. So if I want one command that will show me the key, what can I do? Because I know that the key will be this, followed by this. So here we have 26 letters. We have the 26 letter. Each letter appears exactly one time. And, well, it's very easy to memorize, no? Because I memorize downstream and I can go to this. So if I want just one command to show me this, what can I do? This show me the final part. So what should I do? I need to execute two commands, no? I can show, for example, echo downstream. This is the first command, following by a second command. Now they will be in two different lines. What can I do to put them in the same line? Echo -n. Here is the key if we use downstream. Okay? They give you another example, flow chattings, hydropneumatic. So they say you can also remember a sentence where you eliminate the blank. So for example, you can remember big cat only jump. So you have to remember big cat only jump. So what will be the key associated with big cat only jump? Let me copy it. This is not a word, but the B appear only one time, the I appear only one time, the G appear only one time, blah, 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 blah. Each letter appear only one time. So if I'm going to use big cat only jump, what can I do to get the key? So first I need to remove the space. Remove. D is for delete. Remove the space. So look, we have big cat. Cats, sorry, with a S, only jump. Okay, big cat only jump. Then, what should I do? So this is what I want to remove from the alphabet, isn't it? So look what I'm going to see. I'm going to generate the alphabet. Generate the alphabet. Remove the space when you generate the alphabet. And then suppress big cat only jump from the alphabet. Look at, this is what is left. There is no letter that belongs to big cat only jump here. So the key will be what? The key will be this, followed by this. Okay, how do I show that this string have 26 characters and it have all the letters of the alphabet, if I want to verify that? So first that you have 26 characters. I'm not going to count them. I'm going to ask the computer to count them. So how do I ask the computer to count the number of characters that we have in this string? So there is a command that is called word count. Let me show you. Word count. Huh? There is a command that is called word count. So let me do a man of word count and explain you how to use word count. Let me create first a small file. Let's call it data.txt. USA is in North America. Let's put France is in Europe. Okay. Let me save this file. It's called data.txt. So if I want to count the line, the number of lines, we have 2 lines in this file. So I can use word count -L to say I want to count the number of lines of the file. It's called data.txt, no? Is it? Yeah, so it is in the desktop maybe. So word count -number of line of the file data.txt. Look, these 2 at the beginning say that you have 2 lines. Now if I want to count the number of words, 10 words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words. Correct. You can also count the number of characters. It's going to be challenging to count all these characters, no? But the number of characters is 48. So if I do man word count, it tells me that -L will count the number of lines, -C will count the number of characters, -W will count the number of words. If you just apply without options, it will show you the 3 results. So if I don't put any option, number of line 2, number of word 10, number of character 48. So we have this, and I want to show that these have 26 characters. How can I use word count to show that these have 26 characters? I don't want to count them. For example, show me that the string ABC have 3 characters using word count. Echo word count number of characters. It will say 4. Why? Because the echo, if you don't put -n, put at the end a \n, a new line, go to the next line. So I have to tell it, don't go to the next line, just send ABC. Not ABC, go to the next line. So now it will say 3 characters. So if I want to show that this string have 26 characters, I just put it here. 26. Now I want to show that each letter of the alphabet is once there. If I show that the A is 1 time there, the B is 1 time there, up to the C is 1 time there, I have shown that each letter appears 1 time. What can I do? Okay, look at what I'm going to do. I'm going to first put 1 character per line. To do that, there is many possibilities. There is a command that is called sed, stream editor. On stream editor, have a lot of options. So for example, one option is substitute. This S is to substitute. So I can say substitute a letter with a letter and go to the next line. So to say that, I need to define a block. And then I will say substitute this block with the same block and go to the next line. So to define a block, you put, let me show you substitute first. So over something easy. For example, let's put Jacksonville is in Alabama. And I'm going to say substitute, for example, A with, for example, let's put a star. So if I don't put the G at the end, it will only substitute the first occurrence. So here there is an A. The A was substituted by a star. And just the first time. So if you want to say the second occurrence, you can say that. It will replace the second occurrence of A. So look at, we have an A here, it was not replaced, but the second occurrence of A was replaced by a star. If you want to say all the occurrences, you put the G for global. All the A have been replaced by star. So look, now I'm going to say, I want to replace the A with star, star, star. Jacksonville is in Alabama. So you don't have to substitute 1 for 1. You can substitute 1 for 3, as you can see. Or we can say, for example, change Alabama with USA. Jacksonville is in USA. So you see, it's very powerful. But you can say, for example, I want to change. Let's put James Bond 007. So look what I want to change. I want to change all the capital. Let's put like that. James Bond 007. I want to change all the capital with a C. So here I will have a C of capital, and here I will have a C. And the rest will be as it is. Look at C, C. Then I can say, I want to change all the digits to a D. The digits are between 0 and 7, 0 and 9. So look at capital letter here, digit, digit, digit. And I want to replace, for example, all the lowercase letter with L. So here we have, that was a capital, lowercase, 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 capital, lowercase, 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 then digit. You see, we can do things like that. So we can define things that are much more complex. For example, I want to say, let's put abracadabra. Abracadabra. And we have the bra 2 times. So look. I want to say, for example, yeah. I want to say, I want to change A or a B. I want to change a in a B and a B in a A. How we will do that? with the set command. We can use the tr command. If I use the tr command, I say A in a B and a B in a A. This is abracadabra, where you change the A in a B and a B in a A. But if I want to do it with the set command, how can I do it? Or for example, I want to define, or I want to replace A by 2A. Yeah, this is easy. Or I want to replace any consonant or any vocal. Let's put any vocal with 2 times the vocal. How can I do that? For example, I want the A to be 2 times, the E to be 2 times, the O to be 2 times. How can we do that? So look at, you say, what can you do? You need to replace A, E, I, O, U. Those are the vocal, isn't it? By 2 times themselves. So you are going to define a pattern. And the pattern, you define it between parentheses. And you escape the parentheses to say, don't create a subshell. So you are going to define a pattern. Let's say that I want to suppress the vocal first. So look at, I'm saying that the pattern, if you have an A or an E or an I or an O or a U, replace it with nothing. Look at, I suppress all of them. Now, if I want to replace 2 times, so the first pattern is \1. So I say, put the first pattern, follow it by second pattern. Look at James Bond. So we have AA, EE, OO. You see? So here, between the parentheses, I define a pattern. On this pattern, when I replace it, I put \1. So I can define several patterns. For example, let's say that we have a name, a first name and a last name. And I want to change, first put the last name, then the first name. How can I do that with sed? So look at what I'm going to say. First, there is a word. How can we define a word? This will be either uppercase letter or lowercase letter. One time or several times. So when you want to say one time or several times, you put the plus. There will be a space. Then there will be a second pattern. And the second pattern will have capital letter or lowercase letter, one time or several times. Then you want to replace that with the last name first, followed by a space, the first name then, and that's it. See if it works. So what did I do? I did \2. It did show the same one, so there is a problem. Let's see. Let's say that I want to suppress There is, yes, a space, a second. Doesn't work. It's a little more complex. That's what I'm saying. Let's try something easier before we arrive to that. So I'm going to define a word. By the way, let me put plus here, and I'm going to say, show me the word. So the plus is not working, I have the impression. So if I do that, I don't remember exactly the syntax, but I know the syntax for what we want to do. So what was the exercise? We want to verify now that these are all the letters of the alphabet. So look at what I'm going to do. I'm going to echo that, and I want to separate them, put each letter on a line. So I can do said, substitute letter, I define a pattern with the pattern followed by a new line. Global. So let's see. Look at. We have BI, we have big, cats, only, jump, and the rest of the alphabet. By the way, when I do that, I'm going to put a dash n here, so I don't have, okay, it's go up to, so we have big cat, jump, up to Z. Now, look at what I'm going to do. I'm going to sort a line with the sort command. Look at what we have, the result. A, B, C, D, E, F, G, H, I, J. Maybe it's difficult to see that we have all the alphabet. So I'm going to put them in just one line. So after sorting them, I'm going to say, remove go to the next line. Look at the alphabet. A, B, C. Now it's a little better to see. So I need enter after the Z. I can do it. I can put semicolon echo. So this is the alphabet. So you see this command that I'm putting there just verify that we have 26 letters. They are each there one time and exactly one time. We have a lot of commands in Unix, and they are very powerful. Of course, all those hackers know that, know those basic commands, and they combine those commands to do things that are very powerful. So you need to learn by little some of the commands. Those are very frequent commands. Translate, TR, sed, the stream editor, echo, what else we have seen? EXPR, all those are very common. There is no way you walk in Unix without knowing this basic command. Okay, let me see. I know it's time. Let me see if we are done with that. To see what we will have. Okay, we still have some exercise. Okay, so we will continue from where we left here on Thursday. Okay, I see you on Thursday. Thank you.